Hello, today I will be doing video project 13, which includes sights and sounds and a brief overview of different ways to use MATLAB. First of all, what is a sound wave? A sound wave is a continuous signal that can be sampled to result in a discrete signal. First of all, what is that? Basically, sound waves travel through the air are recorded as a set of measurements that can be used to reconstruct the original sound signal. Different sounds have different waves. Sample frequency, the number of samples taken per time unit, such as per second or per miles per hour. Sound signals are usually measured in hertz. Sounds in MATLAB. MATLAB has several mat files that store for various sounds. The signal vector in a variable y and the frequency in a variable fs. For example, there is chirp, which sounds like this. Then there's a gong, which sounds like this. Then there's laughter, that sounds like this. Kind of long. Then there's splat, that sounds like this. And then finally there is train, that sounds like this. There is also a built-in function, sound, that sends a signal to an output device such as speakers, which is how I got how I was able to show you guys what it sounded like. I basically loaded the function. In this case, let's for example use chirp. I loaded chirp, and then right after I went sound parentheses of y of fs. The fs is the frequency and the y is the variable. So I am loading chirp and then add a frequency. And later on I will show you a cool trick about it. How to call the function. To call a function, first of all, sound of y of fs. Like I mentioned earlier. It will play the sound represented by the vector y. In this case, let's use gong at a frequency of fs. Okay, if you want to hear a gong, number one, you would load the specific variable from MATLAB. Then when you play the sound using the sound function is the one that is stated above right here. So give that a try. You should be done by now because it's fairly easy, and you should hear this. The answer is pretty easy, but like I said, you load the variable, which is gong, and then you use the function sound. Y, which is loading gong at its frequency. What if we want to see sound waves? Okay, you could use the plot function to display the data. Now we're going to try and display a graph for both chirp and train. First of all, we're going to do chirp. So first of all, you do subplot parentheses 2, 1, 1, just standard subplots, and then you would load chirp. Instead of displaying the sound, you do plot of y, which remember it's still loading chirp as y. And then you would change the label if you want and the title. And that's what chirp sounds like, that's what chirp looks like, and this is what chirp sounds like. As you can see, it sounds the way it looks. Next we're going to do train. Now train is the same thing. You load train and then you plot train. You can change the labels and everything. I did it to make it easier. This is what it sounds like and this is what it looks like. Next I'm going to show you a cool trick. You could change the frequency. To do this, it's simple. All you have to do is change fs. Is multiply fs by whatever you want or divide it. Okay, first of all, we are gonna hear the normal one, which sounds like this. Next, we're gonna hear it times 0.5, which sounds like this. A much deeper train because the frequency was halved. Next, we're gonna multiply it by 2, which sounds like this. Because it's much faster, it's much higher, there's a much higher wave count. Okay, the next thing the MATLAB book talks about is pixels. Okay, every picture is made up of 1,000 or even more pixels. Now, okay, and as technology gets better and better, the number of pixels per photo increases. Here's an example of a picture with different pixels. The first picture has 6 pixels. Then it increases slowly. Okay? As you can see, as it gets to the end, this image is much more detailed than the middle one or even the first one. And you can't really tell what it is on the first one. You can clearly tell what it is. Okay? How do pixels work? Each pixel stores a different color. The smaller the pixels, the more detail the picture has. Not necessarily the smaller, but the more amount. The pixels work by having 3 basic colors, and the color combinations are so small that they represent different colors. The basic colors, I believe, are red, white, blue, and green. And because of this, it works sort of like how you learned colors in physics, the color circles. That's how it works. Each color is mixed to make other different colors. They use 3 basic colors. Next, MATLAB's color map. MATLAB has a number of already stored color maps. They include jet and even shades of specific colors. For this example, we will be creating custom color map with just 3 colors: black, white, and red. To really see how the colors work, we are going to randomize the order. First of all, in MATLAB, how does it work? So we shoot a my color map and we make it an array of 3 columns and 3 rows. 0, 0, 0, and next row, next row, 1, 1, 1, and then next, as you can see. And then you have to color map that because you have to make it an whatever color you want it to. And then for this example, I randomized it so you can really see how dramatic the pixels are. And then you just shoot out the image. This is what it looks like. Pretty cool, right? Okay. True color matrices, or RGB matrices, whatever you want to call it. It's another way to represent images. They are 3D matrices. The first two coordinates are of pixels. The third is the color index. Here's how you visualize it. These two right here represent it's sort of like a coordinate plane. This is the y, this is the x of the pixel. So, and then the third one represents color. 1 is red, 2 is green, and 3 is blue. Those are the 3 original colors. Made a mistake earlier, sorry about that. And then the number of matrix can be type: unit 8, unit 16, or double. You have to define it as one of these. It doesn't work unless you do this. Okay? For example, unit 8 is an unsigned integer storing values from 0 to 25. The minimum of 0 is 0, which is represented by black. The maximum is 225, which is represented by whatever the color is. In this case, we're going to make it, I believe, in this case, we're going to use every color there. Okay? The image furthermore displays the function in the 3D matrix. How does it look in MATLAB? This is what it is. You do mat equals zeros of 2, 2, 3, which is going to shoot out a graph of 2, 2, 3. Okay, then you do mat 1, 1, 1. Now this is where it comes from previous. It's going to be the first pixel. The y coordinate is 1 and the x coordinate is 1. So the first pixel is going to be red because the number is 225. Now remember, as we said earlier, I can go back. The maximum is 225, which is represented by whatever the color is. 0 being black, 225 being the purest of colors. Oops. Now, the second one is 1 of 2. So it's going to shoot out 1 over here and 2. That's where it is. And it's 3. So 3 is blue. So it's going to be blue. And then the next one is down here. 2. So you have 1, 2, and then a row, which is 1. And that one's 2. So it's going to shoot out green. And then the next one is this. It's 2, 2, 3. Now 2, 2, 3, but it says zeros. So it's going to shoot it out as black. Now here's the thing, you have to do this, the unit 8, because that's how it is. If you were to do it unit 16, the numbers would change and you would have a much broader spectrum, as would in double. And then at the end, you just shoot the image out and you get that. Which is it's the simplest graph that can be done, but it's the easiest one to see. Here you see the red at 1, 1, 1 and 1. The blue at 1 and 2, the green at 2 and 1, and the black at 2 and 2. That's basically my presentation. Thank you for looking, and that's it. Have a nice day. See ya.